From the Library of Congress in Washington, D.C.
And for the past 10 years, I've been the chief architect of Ball State University's digital media repository, which is not going because my slide isn't going. There we are. Or the DMR, as we call it internally. And for most of that time, I've been also speaking or writing or otherwise promoting the concept of sharing or reuse of assets, digital assets, something that I refer to as the Russian doll effect. For instance, the DMR houses a collection of antique and rare pieces of sheet music. However, the reuse of our metadata allows them to also appear in UCLA's Sheet Music Consortium, the State Library's Indiana Memory Project. They also appear in the Digital Public Library of America, and really anywhere else someone would care to harvest the data. But the thing about this usage pattern is that it is distinctly linear. However, recently I've noticed the emergence of a more cyclical reflexive pattern in which the usage of the assets that we created spurs the creation of related assets, which we can then capture and add to the original, creating this sort of feedback loop where the original assets are augmented with layer after layer of meaning. I have several examples of this. However, since this is a lightning talk, I'm going to limit myself to three. One complete, one in progress, and one in the planning stages. And I'll begin with the complete one, the What Middletown Read project, which began a few years ago when a literature professor at Ball State began poking around in the attic of our public library. And he found some dusty books which turned out to be the accession catalogs and the transaction ledgers from the late 19th century of the public library. And so we did, as we do with other materials, we digitized them, placed them into the DMR alongside our other collections so that you could browse through them on the page level. We also fully described them to be discoverable and intersearchable with the other DMR assets. Well, we realized that we had a rather unique opportunity here. The accession catalogs tell us what materials are in the library, and the transaction ledgers let us know who was using them and when. So the meaning was really determined by their interaction. So thanks to some NEH funding, we were able to fully transcribe all of these materials, combine them with some pre-existing land and tax records, genealogical and census data, and other local records, allowing researchers to delve into these reading habits explored in very interesting ways along the lines of age, sex, income level, education level. The project was quite successful, earned us quite a bit of national press, so we returned and thinking about what could we do next. So we returned to the DMR, where we house tens of thousands of drawings and blueprints from several prominent 20th century architectural firms. Now these materials have been available online for quite some time. There's 750,000 items in the DMR at this time, so they're amongst those. But we discovered that some of the graduate students in the architectural program were using these drawings as source material to create three-dimensional online models or wireframes, which can be flipped or rotated, enlarged, and zoomed in from any angle. And so we captured and added these 3D renderings back to the original drawings from which they sprang from. Also, we converted the 3D modeling files into 3D printable files, allowing anyone with the correct hardware to print out a model such as what I'm holding in my hand. Having spent most of my career trying to get things onto a screen, pulling something down from a screen and creating something seemed like heresy. However, move forward on that. So it's continuing. We are working further with more models, 3D printable models, and adding this and augmenting it as well as on entire structures. As for the one down the road, we are now in the early planning stages of a new project, which I'm hoping will come to fruition with the David Owsley Museum. The DMR already houses a large collection of artwork images from the museum's permanent collection. However, recently another wing of Ball State, known as the Institute for Digital Intermedia Arts, have begun 3D captures or scans of pieces of sculpture in the museum. Now, they're doing so to create a virtual museum in a Blue Mars environment, but it's my hope that along the lines of the architectural project, we can repurpose this three-dimensional data and layer it onto the existing DMR collection. Additionally, I'm working with the museum's director of education, Tanya Saeed, to create or to repurpose pre-existing instructional materials so that educators anywhere could download a printable model accompanied by a full lesson plan in the classroom. So in conclusion, I'm very excited about this new circular or reflexive pattern where these objects or their manner of usage are leading to new objects, and I'm also out of time, so thank you very much.
All right, hi everybody, I'm Dave Gibson from the Moving Image section of the LSE, and this is, oh, is it doing something? I don't know, maybe I made my PowerPoint too complicated. Oh, that's not good. Huh. I don't know why I would need to do that. Okay, well, maybe my audio won't work, but you would have heard some shredding riffs. Oh, there it goes. Some alien decapitation and some shredding riffs for you. Okay, so just some quick facts. These are the numbers. We've been the keepers of the game since 2006. We have that many games, most of which are published, and we have some other materials in our collection. We also still have source code excerpts and DVDs of gameplay, which were copyright requirements up until 2006 for video games. Some background on the game that I'm going to be talking about. It was developed by Apogee Software. The most important thing you need to know is it was supposed to be the first part of a trilogy. It was developed for two systems, Nintendo DS and PlayStation Portable. The DS version came out, the PlayStation Portable was not released at all commercially. So what I received was this wonderfully packaged DVD-R with this great metadata in pencil at the top of it. So I assumed immediately that it was a DVD-R of gameplay because we have lots of those. But when I looked at the copyright record, I noticed that actually it was listed that the entire video game, computer code, artwork, and music was being copywritten. So when I put it into my computer, this is what I found, and I was very excited about it because I expected a video, and I was especially excited about this image file here. Because as soon as we dug into it, we realized it was the actual entire file directory for the game, including all the assets and the code. So this is the alphabet soup of the file types that are on this disk. 28 different file formats, most of them proprietary to Sony, 1,968 files. I'm just going to keep. Okay, so what did we do? I met with Matt Derby, who's our software developer. We pulled the files off the DVD. Found most of the asset files in the PSP game folder in the user directory, and then we realized it was probably, what was being written to the UMD, the cartridge that is played in the PlayStation Portable. So then we had to figure out how we could get access to these files. We went to the homebrew community. From this website right here is where we found the Noesis program that we realized we needed to access these files. As you'll notice, the senior is dead. He was dead as of 3 days after we first went to this program, so that's to this website. So that's a problem that we're going to have to, work with in the future. So we were able to get access to the GIM and GIMO files. The GIM files are textures and still images, and they're very specific to PlayStation Portable. So here we have a texture for one of the pig cots from the game, and here we have some propaganda posters that are on the background in the game, just in a file like that, which is very exciting to see. Here we have some of the GMO 3D models. So we have Duke Nukem and his trusty jetpack here. We have one of the rat enemies here, flailing around. And there's his skeleton being added there. We have the sniper pig, and my personal favorite, the dying talker, who does a pretty cool dance there. So we also use Media Coder to convert the audio files to MP3. And just as a warning, you guys, let's see if it plays. It might not play. Oh, yeah, there it goes. Just calm down. Okay, so they're assembled, so be careful. Anyway, so we got some metadata from Media Coder also for the audio files, the AT3 and VAG audio files that were on the disk. And then we used a hex editor to open the boot bin to see the ASCII text, which included, in this picture, as you'll see, some uncompiled source code, and also the text for all the source code, the text from the game, the credits, etc. So we were very excited to see that this game, in fact, did have source code on it. So the obstacles moving forward, the reliance on the homebrew community, as you could see, that website was dead, 2 days after we used it. No infrastructure in place right now at the library for researcher access to this stuff. Difficulties in cataloging unpublished, much less published software, and the reluctance on the part of the game companies themselves to send in these disks because most of it is trade secrets in their view. But we now have the ability to preserve an unreleased game like this in its pre-compiled state, opportunity to provide researchers access to game mechanics and source disks, and also it fits in with the recommended format specification, which you'll hear more about tomorrow. But it would be nice to say we've received something like this. It would be nice for preservation purposes to receive more of them in the future. Thank you to Matt Derby. This is my information to my colleagues. So if you have any more questions, you can take a picture of that really quickly. And here's some more Duke Nukem audio for you. So all of that stuff, all the audio has come from the actual disk itself. So very exciting. Thank you very much, everyone.
Good afternoon. My name is Becky Katz, and I'm an Assistant General Counsel to the Council of the District of Columbia. Today, I am going to talk to you about UELMA, the Uniform Electronic Legal Material Act. This is a uniform act that says if a state passes it, and if that state says that its digital legal publications are the official publications, then the state has to make sure that the publications are preserved in some way. So a lot of states are keeping their paper publication, their print publications to fulfill the requirement, but here in DC we have a different goal. We actually do want to preserve our digital publication. I say this as a young-ish attorney. I nevertheless keep at least 3 volumes of our hard copy code on my desk at any given time. But I do think that for long-term access, we do want to be preserving our digital content. And as you know, that introduces a lot of questions. Like how? We don't know what technology is going to look like next year, let alone 10 or 20 or 50 years from now. So our first decision was that we wanted our preservation solution to be open source. And I know I saw at least one vendor, and I don't want to hurt anyone's feelings, but we've been burned by proprietary products in the past and want to avoid that. The next question is formats. We think that a lot of states, when they go past print publications, they are going to default to PDF. But PDF isn't necessary for the security of the records, and we think the common tools for authenticating PDFs aren't open source. And of course, XML is, the solution to everything, or not. But that's what we are going to use as we go forward. Let's take a step back and look at why I'm working on this project at all. I am an attorney for the DC Council, but I'm also a library student, which means that I've learned just a teeny bit about digital archives, and my professor, who I learned this from, is giving one of the lightning talks tomorrow. So if we look at preservation like in archives, we are going to ask about metadata. And of course, there's a lot of scholarship out there about metadata for preservation, and many of you have been responsible for that scholarship, so thank you. We have a lot of metadata standards: MET, CAD, Dublin Core, Premise, I could go on. We haven't decided what makes the most sense yet for us at the DC Council, so come find me and sell me on your favorite. All the metadata in the world, of course, won't mean anything if the records aren't usable, which could mean the back-end ability to recreate the records if something goes wrong, or it could mean the front-end ability to use any records in the repository easily and efficiently. I vote for the latter. We want to have a single user face that integrates with the preservation repository. And like Carl mentioned earlier, with system evolution, digital records, unlike paper, actually use helps with the preservation. Of course, no matter what decisions you make, you want to make sure that you document them, preserve not only the text of the laws, but also data dictionaries, how to render the XML on screen, and so forth. Right now, my boss and I are really excited about this project, but we also know that sooner or later, he and I are both going to have different jobs. And so what's going to happen? It's kind of the type of project that's not going to get a lot of attention unless someone really messes up. So we think that it's important that it be an explicit part of a single person's job description. And finally, we shouldn't try to preserve our digital content on our own. One of the reasons why we trust books is that each book has a lot of different copies. So we think that states that are implementing UELMA should be sure to develop agreements with law school libraries, court libraries, other organizations, for those entities to automatically harvest or scrape or download or upload or whatever language you want to use, updates in order to ensure that there are many copies. And with that, I will conclude simply by saying that I hope to work in partnership with each of you on this and other projects in the future. Thank you.
Hi, everyone. My name is Kate Murray, and I'm from the Library of Congress. And along with my co-chair, Andrea Goethals, I am the co-chair of the NDSA Standards and Practices Working Group. And I'm here today to introduce a very soon-to-be published paper about Fixity. Here's one of the iconic photographs in the Library of Congress collections, taken in 1936 by the great FSA photographer Dorothea Lange. The formal title is Destitute Pea Pickers in California, Mother of 7 Children, age 32, Nipomo, California. But it's probably better known by its alternate title, Migrant Mother. And incidentally, this digital file was made from the original negative. There's a poster with this image just around the corner from my desk, so I thought it would be a good choice to help me illustrate Fixity. As an aside, it was not until I pulled this image for this presentation did I realize there was actually 3 children in it. I never noticed the baby in her arms. I thought that bit in the corner was just additional folds in her sleeve or a blanket, but it turns out there's a human being there. So anyway, let's imagine this digital image is living on a managed storage system in a digital preservation environment. And then in the way of these things, the file is moved from one storage component to another. This is a magical and mysterious process best represented by nebulous clouds. When we next see our well-known image after the storage migration, we realize right away that something's changed. There are still 3 children, we're happy to know, but the entire image is flipped. The bits comprising the image on the new storage media are not identical to the bits comprising the image on the old storage media. This change is a problem in a digital preservation environment which requires continuity and stability. It was pretty easy to tell that there was a change between those 2 images. After all, the change was big, dramatic, and frankly obvious. But what if there are thousands or hundreds of thousands or millions of files? Without opening up each one, how would we know that this change occurred? And what if the change was less obvious to spot? Here's a less human readable view, for some of us, of 2 files. These files are supposed to be the same, but are they? Surprise, right? This is just another representation of our migrant mother images with the original orientation on the old server and the flipped version on the new server. Actually, the only thing that is the same about these 2 files, or at least the portion I've abstracted for you here, is a signature identifying these both as JPEG, and that's highlighted there in orange. So no, these files are not the same, and yes, there is change, and if you stared at these long enough, you'd figure that out. But surely there must be an easier way to determine if files that are supposed to be the same really are the same. And there is. It's called Fixity. Fixity is the property of a digital file or object being fixed or unchanged. In this sense, it's synonymous with bit-level integrity. Fixity information offers evidence that one set of bits is identical to another. The most widely used tools in creating Fixity information are checksums like CRCs, or cryptographic hashes like MD5 or the various SHA algorithms. Other data points, such as expected file size and file count, can also provide basic high-level fixity information. So here's an example of fixity in action for our migrant mother images. The MD5 hash value of the original image on the top does not match the hash value of the so-called flipped image on the bottom. Some sort of change occurred. At this point, I don't know what that change is or its extent. But because I compared the fixity data generated before the file was moved to the fixity data generated after the file was moved, I know that the bits within the file on the new storage system are not identical to the bits within the file on the previous storage system. The bit level integrity is broken. These two files are not the same, and they should be. And that's a problem within a digital preservation environment. Of course, while fixity data can alert us that a problem exists, it doesn't tell us what to fix or how. If you want to know more about how, when, and how often to check fixity, the NDSA Standards and Practices and Infrastructure Working Groups are finalizing a discussion paper to help digital preservation stewards answer these questions in a way that makes sense for their organization based on their needs and resources. The paper includes information on why fixity is important, general approaches to fixity check frequency, advice on to where to store fixity data, as well as characteristics of common fixity instruments. We expect the paper to be published on the NDSA website in the very near future, but you can get a preview through this post on the Signal blog. And thanks very much. Before I get the hook, I just want to give a shout out to our NDSA Standards and Practices Stumbling Blocks to Preserving Video survey. These should be on, these bookmarks should be on your tables, and we'd love to have you guys fill them out, and we'll be analyzing those results and getting out to you soon. Thank you.
Good afternoon, everybody. My name is Krystyna Ohnesorge. I am a head of Information Preservation Division in the SFA, Swiss Federal Archives, a member of Executive Committee of the SFI. I would like to talk to you about how to preserve databasing using SIARD. Many of our Swiss institutions need to archive their databases. For example, the Federal Statistic Office, which has various census data, or Federal Office for Migration with personal data on migrant groups. Other examples are the Federal Department of Defense, which collects personal data on the courses of military services. Yet other example is data steaming from the information system of the Federal Intelligence Service. In this context, we are concerned with the following questions. How can we preserve the database content for the long term, and how we can be sure that we will still understand the content in 20 or 50 years? How we can preserve database content independently of any specific database product? Nowadays, there are various types of databases, such as hierarchical databases, object-oriented, network-oriented, or relational databases, etc., which require individual archiving solutions. In the Swiss Federal Administration, about 90% of specialized applications are based on relational databases. For this reason, the SFA has focused mainly on relational databases and have developed a unique archival solution. We developed the SIARD format, an open, published, standardized archiving format for relational databases, and we provide a software tool called SIARD Suite to convert databases into the SIARD format. We often use applications that are based on relational databases, such as Oracle, MySQL, SQL Server, or IBM DB2, etc. The problem with those databases is that they are product specific and their specifications are not freely accessible. Hence, they are not suitable for long-term preservation in the SFA. The SFA's archiving strategy is based on the migration principle. According to this principle, we keep digital data in formats which are adjusted to changing conditions in the environment whenever needed. Thus, it is guaranteed that we can still easily use the data in the future in different environments. The key to long-term preservation in the SFA is always using open, published, and standardized file formats. In order to preserve a database, all relation in a database should be preserved. All tables must be archived together. It is not sufficient to convert databases tables into a format suitable to the long-term preservation. The values in the fields must be also converted. With this in mind, the Swiss Federal Archives have developed a method to store databases as a collection of XML files contained in a compression-less zip archive. With the SIARD format, a database can be normalized and store for future generation in a format appropriate to archiving. SIARD is a short for Software Independent Archiving Relational Databases. In early 2013, the SIARD format has been adapted as a Swiss national standard. It is also recommended by other national archives in the European community, for example, the national archives in France and Germany. Together with the SIARD format, the SFA have also developed a freeware tool, SIARD Suite, that converts databases into an easy-to-handle single SIARD file. That file can be uploaded in a new database that may differ from the original. Therefore, SIARD Suite can be seen as a conversion tool, which allows to retain data independently of the original database and to reuse them in the future in the modern database systems. Further, the SIARD Suite is a platform-independent tool. It operates in a Java 1.5 environment, Windows, Linux, and Mac. What's more, the installation is very simple. SIARD Suite can be used directly from the USB stick or simply click and install SIARD Suite from our websites. As you can see here, SIARD Suite is already widely used nowadays. We have issued over 300 licenses in 54 countries. In the United States, it has been distributed 30 times so far. Although we don't know how frequently the tool is actually used, we do get a lot of questions regarding the use of both SIARD Suite and SIARD format. So in conclusion, if your institutions need to archive relational databases, please don't hesitate to order SIARD Suite or use the SIARD format and build your own application. Try out the simple but effective archiving solution yourself. Thank you very much.
This has been a presentation of the Library of Congress. Visit us at loc.gov.